Bismillahirrahmanirrahim. Hello everyone, I hope you are all fine. I welcome you all to the real analysis class. So far we discussed about field and ordered field. In today's lecture we will discuss some important propositions uh, that can be satisfied for any field f. Actually these are the some additional properties of addition and multiplication that hold for any field f. So in today's lecture we will discuss two important propositions from your book Principle of Mathematical Analysis by Walter Rudin. The first proposition says that if f is a field, then for any three elements x, y, z belong to f, following axioms of addition hold in f. For any field f with two binary operation addition and multiplication, following axioms of addition hold in f. The first axiom is that might be invisible here. If x plus y equal to x plus z, then we need to show that y equal to z. This is the first axioms that we have to prove here. So how we will prove this? The first method that I will discuss here to prove this, that is the very simple by using the left cancellation law, or by taking simply the additive inverse of minus x on both sides of the given equation. The given equation is x plus y equal to x plus y, x plus z. By taking negative x, that is the additive inverse of x. Here it is important to note that because f is field, so field f, actually what is field f? A field f is a non-empty set that satisfies the 11 axioms. 5 axioms are axioms of abelian group under addition, and 5 are the abelian group of multiplication for non-zero element of f, and the 11th property is the distributive law. So if x belong to field f, then due to f is a abelian group under addition, minus x will also belong to f. So we can take here additive inverse of x on both sides. In this equation we have minus x plus y equal to minus x plus z. Here we will prove all of these properties by logically by giving by mentioning properties of field. So by using associative property, next we will write by using associative property, this will become minus x plus y equal to minus x plus z. Next we mention here because x and minus x are the additive inverse of each other, so their sum will be 0. So this is 0 plus y equal to 0 plus z. Now we mention 0 is the additive identity, so when we add 0 with any number, it will not affect that number. So this will become y equal to z. So this is the one of the method to prove the first axiom. The second method is here. As we can write y equal to 0 plus y, because 0 is the identity, so we can add 0 with y. It will not change in y. There will be no change in y. Now, because 0 can be written as minus x plus x, so we replace 0 with minus x plus x. Next, by using the associative property here, this can be written as minus x plus y. Next, because it is given that this x plus y equal to x plus z, this is given, so we replace x plus y equal to x plus z here. That is this minus x plus z. So this step will become this. Next, whereas the your left side is y equal to this. Now, by applying associative property in these two elements, this will become minus x plus z. Now minus x plus x is equal to 0. So this gives us y is equal to z. Hence proof. In the second property, we have to show that if sum of the two number x and y is equal to x, this is possible if y equal to 0. This is the second property. If the sum of the two numbers of any field f is equal to the one of the number, that is x here, this is possible if y equal to 0. Okay. You can write simply x is equal to x plus 0. So we replace x is equal to x plus 0. Now by applying the left cancellation law on both sides, by using the left cancellation law of both sides, we have y is equal to 0. That is required. Next, very simple property, if sum of two number is 0, mean to say they are the additive inverse of each other, then the second number y can be written as negative of the first. We have to show that in the third axiom, given that x plus y is equal to 0, this implies y is the negative of the first. This is our requirement. So we can write it as 0 can be written as x plus minus x. That is actually 0 is the sum of these two numbers. These numbers are additive inverse of each other. So 0 can be replaced with these numbers. By using left cancellation law, x will be cancelled. So we have simply y is equal to minus x as required. This is the very important property. We will use this property in our next axioms. Fourth property. In the fourth property, we have to show that negative x plus x is equal to 0. To prove this property, we will use the property number 3, which says that if x plus y equal to 0, that is the sum of two number is 0, then second number is the negative of the first. You can see here, this is also sum of two numbers and their sum is 0, it is given. So by using 3, x can be written as, this second number can be written as the negative of the first by using this result. That is required to prove. So this is the first proposition in your book. Now we will discuss the second proposition, that are actually the properties of multiplication. So we prove that these properties with the same concept that we have used in proof of properties of additions. Okay. Proposition 1.2. If f is a field, then for any x, y, z belong to f. Now x is non-zero because these are the properties of multiplication. Following axioms of multiplication hold in field f. The first property is, if the product xy equal to xz, then we have to show that y equal to z. This property is same as the property number 1 of addition, that was x plus y equal to x plus z, then y equal to z. You can simply apply the multiplicative inverse of x on both sides, because f is field, and if x belong to z and x is non-zero, so the multiplicative inverse of x will hold in f. So we can take multiplicative inverse of x on both sides of the expression, that will become cancel and become 1. That is the multiplicative identity. So after multiply 1 with y and z, there will be no change in y and z. This will become y equal to z. This is the first method to prove this equation, this axiom. The second method that can be used here to prove this, as you can write y is equal to 1 into y, because 1 is the multiplicative identity, so there will be no effect on y, so y can be written as 1 into y. Now 1 can be written as, or can be replaced with 1 over x into x, because x and 1 over x are the reciprocal of each other, so 1 can be replaced with 1 over x into x. Now by using the associative property here, 1 over x into y, this will become, now this bracket x into y, this is given that xy equal to xz, so we replace xy with equal to xz, we have here 1 over x into xz. Then again by using the associative property 1 over x into x into z, whereas your left side is y. 1 over x into x, this will give us 1. This implies y equal to z as required. Second property. In the second property, we have to show that if the product of two number is equal to one of the number, if xy is equal to x, then this is possible if y is 1 here. This is our requirement. If the product of x into y equal to x, this is possible if y is equal to 1. The right side, that is x here, can be written as x into 1, because you know x into 1 is equal to x, because 1 is the multiplicative identity, so that's why x into 1 equal to x. So replace x is equal to x into 1. Now by using the left cancellation law, simply x will be cancelled, so y equal to 1 as required. Third property. In the third property, we have to show that if the product of the two numbers x and y equal to 1, then y is equal to 1 over x. In this property, we have to show that if the product is equal to 1, then y is equal to 1 over x. That is the second number can be written as the reciprocal of the first. If xy equal to 1, then we can say that y is equal to 1 over x. That can also elaborated as the second number y is the reciprocal of the first. So can we write 1 is equal to x into 1 over x? Yes, 1 is equal to x into 1 over x. Now simply by taking left cancellation law, by applying left cancellation law, x will cancel x, because here x is non-zero, so we can apply left cancellation law here. But if x is 0 here, we cannot apply left cancellation law, because it leads to indeterminate form, 0 over 0 form. So by left cancellation law, x will be cancelled, this will become y is equal to 1 over x here. That is required. In the last property, property number 4, or in a fourth axiom, we have to show that if the product of the two number is 1, this is possible if the second number is the reciprocal of the first. In this property, if the product of the two number is 1, we have to show that this implies x can be written as 1 over 1 over x. So we use, to prove the result, we will use the concept of 3, that says that by using 3 says that if the product of two number is 1, then the second number, that is y, can be written as the reciprocal of the first. So if we apply the concept, this concept on the fourth property, if we take this is y, so this is our y, that is the second number, can be written as the reciprocal of the first. Reciprocal mean 1 over something, that is 1 over x. So by using 3, we can show that x is equal to 1 over 1 over x. So these are the two propositions that we have discussed in this lecture. Inshallah, in the next lecture we will discuss an important proposition that is also related to the field F. And I hope today lecture was helpful for you, and now you are clear about today lecture. Okay, take care. Allah Hafiz.